This lab is Network Time Protocol. What I'm going to do in this lab is show you how to configure a Network Time Protocol. I've got a basic topology here. I've got 4 routers, R1 and R2. They're going to be configured as NTP clients. They're also going to do peering. There's also R3, and that's going to be an NTP server to R1 and R2, in addition to the redundancy for peering between R1 and R2. There's also this NTP master, and this is simulating a public NTP server. And public NTP servers are connected to an atomic clock with stratum 0. So I'm going to configure NTP master to be stratum 1, and that means that R3 will be stratum 2, and R1 and R2 will then be assigned stratum 3. There's also OSPF configured between R1, R2, and R3, and that's for routing. There's also a static route from R3 to this NTP master with hostname pool.ntp.org. So the first thing I'm going to do is I'm going to enable debug and log timestamps on all routers for NTP messages. Then I'm going to configure a time zone with daylight standard time and use the recurring keyword in all routers. And the purpose of that is to, along with the time zone, the recurring enables the translation from daylight savings time to standard time. Then I'll configure the NTP server on R1 and R2 as R3. The result is that R3 will provide time synchronization for R1 and R2. I'll also configure pool NTP.org as the NTP server for R3. In addition, I'll also configure peering between R1 and R2. That'll be redundancy only. That's only a backup if there's no synchronization from R3 as an NTP server. I'm also going to configure the loopbacks on all the routers as the source for NTP messages. And also I'm going to synchronize the hardware clock on all the routers to the NTP time source. Then I'll verify the NTP is working with show NTP status and show NTP associations. So to start with, I'll go to pool NTP.org. So the first 2 commands at the top, this is for timestamps. Service timestamps, debug, date time milliseconds, and also service timestamps, log date time milliseconds. So that'll put the timestamps on the NTP messages in milliseconds. I've also assigned hostname pool.ntp.org to the NTP master. And like I said, it's simulating a public NTP server. Clock time zone, I've used Pacific Standard Time with an offset of 8, since I'm in the Pacific time zone. And clock summertime, Pacific Daylight Time, recurring. That'll make sure that that change happens twice a year between daylight savings time and standard time. Then there's clock calendar valid, and that command's only used on the NTP master since I want to use the hardware clock as the time source. I've also set up the NTP master as a DNS server. I've got this IP host pool NTP.org 192.168.255.4. So that's just doing the name to IP address resolution for DNS. That's for R3 that's going to use the host name instead of IP address. And the 192.168.254 is a loopback. And there's the loopback there, loopback 0. There's the IP address. And I've got interface gig 00, and this is the NTP public time server link to R3, 172.33.12. That's that link there, gig 00 to R3. I've also got a static route to R3 as well, instead of doing dynamic routing. I've also configured NTP authentication as well, using MD5. So it's got a password, it's encrypted since it's using MD5. That has to match on all the routers. NTP authenticate, NTP trusted key 35 is the arbitrary number I use there. There's NTP source loopback, so all the NTP messages to R3 will be sourced off of the loopback. And the NTP master 1 command configures it for stratum 1. So that configures the NTP public server. Now we'll go into R3. At the top here, I've got the same 2 service timestamps commands, and the clock time zone Pacific Standard Time, and clock summertime PDT recurring. I also have this IP name server 172.33.12. This is pointing to the public NTP server configured as a DNS server. Then there's the loopback address 192.168.2553. And that's the link to the public NTP time server. There's the address, 172.33.11. We've also got two links here. One goes to R1, and that's in the 192.168.2 subnet. And the other link to R2 is in the 192.168.3 subnet. I have OSPF routing configured here, and this is for the connection to R1 and R2. I also have a static route here, and this is for the connection to the public time server. And again, at the bottom here, I've got the NTP statements. I've got the NTP authentication key command, and NTP authenticate, and NTP trusted key. And as mentioned, the password has to match between all the routers for that to work. And NTP source loopback, that just sources the NTP messages from the loopback interface. And the NTP update calendar, that tells the router to update the hardware clock based on the NTP time source. And NTP server pool.ntp.org, that configures the public time server as the NTP server. It's a time source for synchronization. Now we'll go over to R1. And same thing, the service timestamps commands in clock time zone and clock summertime, PDT recurring. Then the loopback for R1, 192.168.255.1. There's the link to R3, and that's in the 2 subnet. And the link to R2, that's a peering router, 192.168.1 subnet. And I have OSPF configured. And at the bottom, there's the NTP authentication commands. They're all the same. NTP source loopback 0, and the NTP update calendar as well. And NTP server is 192.168.2.1. So for R1, it's going to be 192.168.2.1. That's the source interface there. And the NTP peer, this is 192.168.1.2. This is the 192.168.1 subnet, and there's R2 192.168.1.2. Now we'll go to R2, and same service timestamps, and the time zone and summertime commands. Everything looks fine there. And the loopback is 192.168.255.2, and the link to R3 is in the 3 subnet, 192.168.3. And the link to R1 is in the 192.168.1 subnet. That's correct. And it's got OSPF configured. And NTP authentication is all configured here. And NTP source loopback 0, the NTP update calendar command, NTP peering to 192.168.1.1, and the NTP server is 192.168.3.1. There it is there, 3.1. There's R2 to R3. Now I'm going to do some verification. I'll go back here. I'll just do show NTP status. And here, this is clock is synchronized, stratum 1, that's correct. Reference is local, so that's using the hardware clock as the time source for NTP. It also shows the NTP uptime in seconds, right there. And the last update 15 seconds ago. So everything looks fine there. I'll go to R3. And clock is synchronized, stratum 2, that's correct. Stratum 1, stratum 2 is R3. The reference source is 172.33.1.2. That's this interface here, 172.33.1.2 is where it's pointing to. And it's got the uptime as well, and last update 6 seconds ago. So it's active. Now we'll go to R1. And clock is synchronized, stratum 3. That's correct since R3 is stratum 2. Reference is 192.168.2.1 for R1. That's 192.168.21 there, gig 01. And everything else looks fine there. And finally, I'll just go to R2 and do the same thing. As I mentioned, the pairing between R1 and R2 is only a failover. It's not a primary. Clock is synchronized stratum 3. This is on R2, so that's correct. Reference is 192.168.31. There it is there, 192.168.31. And everything looks fine there. It's getting updates and synchronized. The other thing is just this other command, associations. And show this, so you got this here, the asterisk, 172.33.12. That is what's the current peer. And it's local, so that's the hardware clock. And at the bottom here just shows if it's a candidate, it'll be a plus, or if it's selected, however, hasn't synchronized, then it would be that pound symbol. I'll just go to R2 and do the same thing. And there it is there. See, the second line is the one that's currently pairing with 192.168.31. The candidate, that's plus, that would be the failover 192.168.1.1. That's the top line. So that looks fine there. That looks really good. You notice as well the 192.168.31, that's pointing to a stratum 2, since R3 is a stratum 2. However, the top line, that's the candidate, that's the failover to R1. This is showing a stratum 3, since R1 is a stratum 3. So that's correct. And finally, I'm going to go to R1. Just verify that. And same thing. It's got it as the top line. It's a system pair right now. 192.168.2.1. So that's the primary. 192.168.2.1 R3. And the candidate or the redundant or the failover, however you want to say it, is the 192.168.1.2. And that concludes lab. This lab is SNMP and syslog. What I'm going to do in this lab is show you how to configure syslog services as well as SNMP services for Cisco network devices. So to start with, the topology's got 3 routers, R1, R2, and R3. R3 router has a syslog server connected, and the IP address is 192.168.201/24. There's also a network management station, that's an SNMP server, and that's at 192.168.100.1/24. R3 is also configured as an NTP master, and that's going to provide time synchronization to R1, R2, and switch 1. To start with, I'm going to enable timestamps for logging messages and based on local time zone. I'm also going to enable timestamps for debug messages and also based on local time zone. I'm also going to configure a syslog server and enable sequence numbers for logging messages. I'm going to configure a 64K local logging buffer and enable information level messages. I'm going to configure rate limiting of informational messages only to the console at 15 per second. I'm also going to configure SNMP version 3 with authentication and encryption on all devices. Also configure a CCNP user named CCNP admin and assign that user to group CCNP, and also enable an SMP view and call that any, and I will assign ISO level, and that's the SNMP route. So it'll include from the SNMP route down. I'm also going to configure switch 1 to send syslog messages as traps to the SNMP server. That'll be unique to the switch 1 server only. We'll also configure a local time zone and recurring daylight savings time, and configure R3 as an NTP master. And then finally, I'll verify the logging configuration, NTP, syslog, and SNMP operation. Now to start with, I'll go to switch 1. So there's the service timestamps at the top here. I've got the debug, date, time, milliseconds, local time, show time zone. And that assigns the time zone correctly. And also service timestamps, log, date, time, milliseconds, local time zone as well. I've also got service sequence numbers. The reason is if you get several messages that are all at the same second, it'll assign sequence numbers so that you can distinguish between different syslog messages that have the same time. And logging buffered 64,000 informational, so that'll buffer all messages from informational and lower. And logging rate limit console all 15 except notifications. And what this will do is rate limit informational messages. It'll do it 15 per second. And as a result, all messages from notifications and lower are not rate limited. Then I've got a username CCMP admin, that's a local account with privilege 15, a secret password, and a clock time zone in the offset. I've also got clock summertime PDT recurring. And the purpose of recurring keyword is to make sure the switch between daylight savings time and standard time occurs twice a year. Got a loop back as well, 192.168.2554. I've also enabled web management access with the IP HTTP commands, authentication local and secure server. Then on switch 1, since I'm sending syslog messages as traps to the NMS server, that's the SNMP server, I've also added logging history size 10. That command will store up to 10 messages in the router history table. It'll also store them from the error severity level and down. Then there's logging facility local 6. And what this does is the standard for Cisco is to use facility local 7. And that's just the default, so you don't see it in the actual run configuration. So what I've done here is I've changed this to local 6. So what this will do is create a new log file just for the switch. I've also assigned the same local 6 to R1 and R2, so you can differentiate between different log files based on device, and that's all that's doing. I've left R3 at local 7, the default. So there's two different log files. R3 router is another device type since it's got some service connected. Then I've got logging source interface loopback 0. That just uses the loopback management interface as the source interface for syslog messages. And logging host 192.168.201. That is the syslog server there, 201. And also access list 99 permit 192.168.100. And the purpose of that standard ACL is to assign it to a view so that only hosts within that ACL are permitted access to SNMP based on that view. I've got some SNMP server commands as well. I've got SNMP server group, CCMP, that's the name of the version 3 group. It is v3, so with CCMP is the name of the group. It's priv, so with CCMP v3 you can have 3 levels. You can have no authentication, no encryption, or you can have authentication but no encryption, or you can have authentication and encryption. If I use the priv keyword, that will enable authentication and encryption for the group. And then I've got the access read and write access, and access 99 points to the ACL. There's also a SNMP user called CCMP admin. It doesn't show up in the running configuration. That's normal for SNMP version 3. And the view is called any. It's got ISO included. So the ISO is the SNMP root. So it includes everything below that, enables a view to all the SNMP MIBs. I've also got SNMP server trap source loopback 0. So any of the SNMP traps that go to the NMS server are going to use the loopback as its source address. Then the command SNMP source interface informs loopback 0. So I'm sending informs instead of traps. And the reason I'm doing that is informs will provide a reply from the NMS station, whereas traps don't. That'll be sourced off the loopback. Then what happens whenever SNMP host is enabled, you'll get these default traps, and that's what this is here. They are default commands. The one I added was SNMP server enable traps syslog. And what that command does is it will actually send syslog messages as traps to the NMS station. That's only configured with switch 1. And at the bottom here, I've got NTP source loopback 0. That's just the NTP messages. We use loopback 0 for communication. NTP server 192.168.2553 is for the NTP server. And now we'll go on to R1. I've got the same service timestamps configuration at the top here. So there's no change there. Same service sequence numbers. Logging buffered 64,000 informational. And the same logging rate limit command for the console. and the time zone there in the recurring command. Also got this username CCMP. I mean, that's the local account. And the loopback interface 192.168.2551. And I've also got the IP HTTP commands for web management. And here's the logging facility local 6. Switch shares the same with R2 and switch 1. And the same logging source interface loopback 0. That's for syslog messages. And the logging host 192.168.201. That's the syslog server. The only difference here is there's no logging history commands since all syslog messages are being sent to the syslog server. They're not being sent as traps to the NMS station. There's the SNMP server commands, the group CCMP using priv security. And there's the view NE, ISO included. And it also has the same trap source and source interface commands, loopback 0. So it's the same thing. There's the access list for the SNP view. It's also configured for NTP. Since R2 has the same configuration as R1, I'm going to go on now to R3. In R3, service timestamp, debug, and log. Yep. Show time zones, sequence numbers. Looking at the logging buffered command, that's okay. Logging rate limit, console, accept notifications. Clock time zone, recurring. And username CCMP admin, correct. Privilege 15, secret 5. It's got a loopback 192.168.2553. And there's the web management commands, IP HTTP. Logging source loopback. Logging host 192.168.201. Yep. Same group, CCMP. Everything looks fine there. And no problems there. And at the bottom, it's the NTP master, and I've assigned it stratum 3. So that means when I do a verification, R1, R2, and R switch should be stratum 4. Assign the messages to loopback 0. The other command is clock calendar valid, and when you set up an NTP master like a router, you have to get the time source from somewhere, so that just gets it from the hardware clock on R3. Now I'm going to do some verification. First thing I'm going to do now is verify NTP status and then logging. So I'll go to switch 1 here. So clock is synchronized, stratum 4. The reference is 192.168.2553. That's of course right there. That's R3 loopback. 192.168.2553. And it's going through. Everything looks fine. NTP uptime, that's in seconds, 854,000. So that's been up for a little while. And last update, 4 seconds. That's all I'm interested in. I'll go to R1 and look at that. Clock is synchronized, stratum 4. Reference 192.168.2553. Great. And it's getting updates. Last one was 35 seconds. And this is R2. Clock is synchronized. Stratum 4, 192.168.2553. And last update 112 seconds ago. R3 is the master. NTP. Clock is synchronized. Stratum 3, so it's one higher level. Reference is the local clock. That's what that 127 is. Last update 6 seconds ago. So everything's fine there. Now I'm going to do show logging. Start with switch 1. Show logging command. 18 messages rate limited. And console logging is on. 70 messages logged. Good. Buffer logging level informational. 89 messages logged. And it's logging to 192.168.201. Now R1. R1 syslog logging is enabled. Yeah. 3 messages rate limited. Console is logging. 54 messages logged. Buffer logging level informational 55 messages. And it's got the correct 192.168.201, so that's correct. 192.168.201. So there's the messages. Everything looks fine there. There's the logging to source interface, loopback 0. And just to verify on R2. And syslog logging is enabled. Yeah, 3 messages rate limited. Console logging, 48 messages logged. Buffer logging level informational, 49 messages. And logging to 192.168.201. We've got the loopback 0 there for the logging source interface. And this is on R3 now. Syslog logging is enabled. 3 messages rate limited. Console logging, 42 messages logged. Buffer logging level informational 43 logged. 43 messages logged. And logging to 192.168.201. UDP port 514 is for syslog. And loopback 0 on the source interface. Log buffer 64,000 bytes. So everything looks pretty good there. Now what I want to do is test the syslog server is working okay. So I'm going to shut this interface gig00 here, and that'll generate an interface down syslog message to the syslog server. There it is there. There's an adjacency change too. Now I'll go to syslog server. CD bar and CD log and more syslog and catch syslog. This server is a Docker container. It's a Networker's Toolkit. Notice this is Linux. Oh, wonderful. There it is. You see all these commands here being sent. So right at the bottom here, I've got the adjacency change and the gig00 from full to down. This is what happened when I turned that interface off. So that's there. Now I'm going to re-enable R1. Should send some more messages. There's some more there. Timestamp 339, remember that. So it's reloaded it. And notice gig00 is up here, change state to up. Notice the adjacency as well for OSPF is loading to full. So syslog server is working correctly. Now I'll verify SNMP. So I'll start with R3 and just do show SNMP. This command has some SNMP statistics. You can see right here, 0 packets input, packets output, any errors with the packets. At the bottom, specifically SNMP informs enabled instead of traps. Informs in flight, none. Logging to 192.168.101. 192.168.101, that's correct. And UDP, and the 162 is the SNMP UDP port. So that looks pretty good. Now I'll just do user, show SNMP user. This isn't shown in the running configuration. The only username is CCNP admin. It's active and group name assigned to CCNP. So I'll go on to the group now. And the only group is the one at the top. Group name CCNP, security model v3 priv. The priv refers to authentication and encryption. So that's the highest level of security for SNMP. And the view is any. That's the name of the view for read and write. And access list 99 is assigned to the group. And that just limits access for a specific number of hosts. You configure a user CCNP admin, assign that to the group, and there's the group. There's also show SNMP host. This gives some quick information on the host. 192.168.101, UDP port 162, and forms are being sent. User is CCNP admin, and the security model is v3 priv. So that's kind of gives you a nice snapshot of how it's configured as well. Now to generate some SNMP traffic, what I'm going to do is just turn off SNMP. I'll just take a look here. And SNMP agent not enabled. Another command. Put the contact in there. There's the correct command there. So here, whenever you use any SNMP server command, it will automatically enable SNMP. I've just used this contact command here. So now warm start, agent on host R3 is undergoing warm start. So it's starting up again. Now what I want to do is just go over to the NMS here. And there it is there. So there's all your SNMP 5.8. At the bottom here you can see these SNMP traps. You can see the connection there, subagent connected. That's what I just did. So logging, NTP, syslog, and SNMP are verified, and that concludes lab. Embedded Event Manager is software that's built into the Cisco iOS. It's essentially a group of CLI commands. And the purpose of EEM is to make automation of tasks much easier for Cisco routers and switches. It also gives you more operational control over network devices as well, such as enhanced monitoring of network interfaces, as well as network security. For example, not permitting a reload of an internet router. Topology only has 4 routers. There's R1, R2 in this internet router. That's connected to a cloud router. Also have a multi-layer switch connected to R1. So what I'll do is I'll go through each EEM configuration, explain it, as well as verify that it's working. To start with, the R1 has 2 applets. It's, the first one is I'm going to configure it to prevent any telnet sessions that originate from R1 router. The other applet, I'm going to prevent changes to ERGRP metrics on the R1 router. Then on R2, there's also 2 applets. First one, I'm going to send an email message with a debug trace when an OSPF adjacency is down on R2. I'm also going to shut down interface gig 00 on R2 when bandwidth utilization exceeds 100 kilobits per second. Then on to the internet router, I'm going to enable a public interface automatically on iNet router when it goes down. Next thing on iNet is I'm going to hide the security credentials in the running configuration. Then I'm going to log all CLI commands to a CLI log text file on flash on the internet router. And I'm also going to prevent configuration of new static routes without authorization on the internet router. I'm also going to prevent reload of the internet router as well. And finally on switch 1, I'm going to do an automation task where I'm going to configure all access switch ports for hosts on switch 1. So to start with, I'll go to R1. Here's R1. At the bottom of the script here, I've got 2 applets. One of them is named No Telnet Out. The other one is named EIGRP Metrics. For applets, you can add a description. This helps as well for troubleshooting purposes. This applet prevents any telnet session originating from this router. And then there's 2 lines here. One of them's an event, the other one's an action. So EM is based on events and actions. There's event detectors. That could be something like monitoring SNMP objects or syslog messages for particular text patterns, or counters or timers as well. The action could be something like run some CLI commands or send an email message, even a message to the console. So for the applet No Telnet Out, I've got an event CLI pattern telnet. So the applet is going to monitor the CLI command line interface for the word telnet when it's typed. When telnet is typed, then that's going to trigger some action. The sync no and skip yes occurs one. This is a key part of all applets as well. Sync no is asynchronous processing, so the CLI command will run at the same time as the applet. So whenever you use the sync no keyword, you also have to use a skip yes or skip no. And skip yes means skip the command, don't permit it, or skip no means it's okay. And the occurs once refers to only allowing the telnet to be typed once for this particular applet. So next time somebody types it, the applet would be run again. So what happens then is the command is skipped. This action writes this message to the console. Telnet command is not permitted from this router. The other thing to know with sync keyword is there's something called an exit status variable. And with EEM, it has one of two values, either 0 or 1. If you use the sync no, it's not going to check that variable, so the command cannot be run. If it's a 1, if you use sync yes, then that will check the exit variable. And there you can decide whether you want to run the command or you don't. The default is to not run the command. Sync no by default would not check the variable. It would use exit status variable 0, and that's the default. And that tells the applet not to run the command. Now to test it, so I'll type telnet. And there it is. So get a message, no telnet out, telnet command is not permitted. So that applet is working correctly, great. This applet will prevent changes to ERGRP metrics. What I'm preventing is any change to the metrics that would have some negative effect on metric calculation in the routing process. And here what I'm using is event tags. The reason I'm using event tags is because there's more than one event statement, pattern, bandwidth, and delay. So it's more than one. That's why I have to use tags. Then there's sync yes for both of them. Anytime somebody types bandwidth on the command line interface, with sync yes keyword, what that's going to do, it's sync yes is referred to as synchronous processing. And as a result, the applet has to finish before the CLI command can be executed. So what happens then is sync yes will check the exit status variable, whether it's 0 or 1. If it's the default, it won't permit any commands, and that's after the applet finishes processing. So somebody types bandwidth, they want to change the bandwidth on a network interface. That'll change the ERGRP since it's based on bandwidth and delay. Sync yes will check the exit variable. I don't have anything configured here, so that means it's going to be 0. That's the default, so it won't be permitted. And the same thing goes for delay. Delay is typed. The same sync yes will do the same thing. So it'll trigger this correlate event here. That will send a message to the console. Bandwidth interface command is not permitted to modify ERGRP metrics. Or if they type delay, the same thing. Delay interface command is not permitted to modify ERGRP metrics. It's just not permitting the commands, and it's just going right to a put message to the console. So I'll test this here. Big T. I'll go interface gig 00. Then I'll try bandwidth. And this applies to all interfaces. Bandwidth interface command is not permitted to modify ERGRP metrics. I'll just try that here, just delay 100. This is microseconds. And same thing. So it gives you both messages. That's working okay. It doesn't permit the command. Next thing I'm going to do is go to iNet1. That's the internet router. And I'm going to test the applets working on that router. So this is iNet here. At the bottom of the script, I've got some applets. First one is no shut interface. And the next one will be applet hide security. Then I've got log CLI commands and no static route. And finally, no reload. So I'll start with the applet no reload. The description, this applet prevents a reload of this router. And that's pretty common with internet routers. You want to really control when you're going to permit a reload of that router. First one, the first event detector is the pattern reload on the command line interface. Someone types reload and sync yes occurs 1. So the sync yes, as mentioned before, It'll detect the exit status variable. I haven't changed it to 1, it's still the default. So it's going to not permit the reload command. It occurs once, means it's just going to occur once, and then it'll restart the app. Then action 1 puts reload command is not permitted on this internet router. That'll be written to the console. So this is easy enough to test, just a reload command. There it is there. Reload command is not permitted. Now I'm going to go to no shut interface. This is the top one here. Description: this applet automatically attempts to enable a public interface. If someone accidentally does an administrative shut on the internet router, this will automatically re-enable it. So what I've got is I've got the event detector. It's a syslog message pattern. So the pattern I'm looking for is anything to do with line protocol, up, down, line protocol interface gig 02. Gig 02 is the public interface. There it is there, 02, that connects to the cloud. That's what I'm interested in. This syslog message is detected, then some CLI commands are run. Enable, config T, interface gig 02, and no shut. It's easy as that. It's quite an easy applet, really. Then just end. So just does a no shut. Then the action is syslog message, gig 02 public interface to cloud has been enabled. So that'll send a syslog message, so you've got that for reference as well. So what I'll do is I'll go and test this. Interface gig 02. And the reason you're seeing these log commands is because I have another applet going that's recording all the keystrokes. Do a shut. So the interface does go down. You can see it changed to down. What happens is then the applet activates and re-enables it. See at the bottom here, interface gig 02, change state to up. So just change it to up, and it sends this message, gig 02 public interface to cloud has been enabled. So it's working fine. I'll go show IP interface brief just to make sure it is. Gig 02 right there, 172.33.11. That's up and up, so that's fine. Next applet I want to do is log CLI commands. So I'm logging these commands, everything that's being typed, to a text file on Flash. This description is this applet logs all CLI commands typed to a CLI log text on Flash. So the pattern is everything. I've got an asterisk there with double quotes, so that means everything. So this skip no is going to say don't skip any of them. That's all it does. So the first action is this syslog priority informational message, and the variable that's creating a message, and it's for informational and down. So everything from informational to emergencies will be logged. Action 2 is file open FH, and this is where it's actually going to write the keystrokes to the Flash file, flash CLI log.txt, and writes a message to the console. Then it closes the file with close FH. And there it is there. It's more flash CLI log text. That will open the file and you can take a look at it. So just showing all the keystrokes there. The next applet is hide security. This applet will hide security credentials in the running configuration. So it'll actually hide the commands altogether. Event CLI pattern SH asterisk run. So that's just any time that show run or show running configuration is typed, sync yes. So that will not run that command. It'll drop right to this action 1 CLI command and run enable. Then action 3 puts, then the CLI result. So what I'll do is remove the applet and show you the security configuration in the running configuration. Now we'll do a show run. You notice here enable password Cisco net's there. And I've also got 3 local accounts: username admin, username CCMP, and username read only. And also at the bottom here, with the VTY lines, there's also a password there. I'm going to add the applet. Notice there's no enable password there. And also there's no local accounts either. Those commands are not visible at all. And right at the bottom there, line V2Y, there's no password for that either. And the last applet will be no static route. That's this one here. Event Manager applet, no static route. This applet prevents configuration of new static routes without authorization. This is preventing anyone from configuring static routes on the internet router without permission. So the first line is the event detector. That's monitoring any typing of IP route on the command line. And sync yes occurs 1. So with sync yes keyword, it's not going to permit it. It'll go to the next line here. Action 1 puts new static routes are not permitted on this router. We'll just send that command to the console. So I'll verify this here. So there's a static route example. New static routes are not permitted on this router. It writes the command to the log. And so that's working okay. So here's R2. What I've got is 2 applets, as I mentioned. One of them's called applet OSPF adjacency error, or OSPF ADJ error. The other one is the interface BW, or bandwidth. So what I've got is I've got an event detector called a syslog pattern. So the applet is monitoring for syslog messages and anything that has OSPF 5, ADJ, CHG, full to down. And that's what is generated when the OSPF adjacency goes down. So that's the event detector right there. Then the action statements, if that's detected, the first thing that happens is the first CLI command is enable. Next one is terminal length 0. Then the next one is syslog priority notification message. R1 at OSPF adjacent to R2 is down, send email notification to CCNP. Then what I do is I start a debug IP OSPF adjacency. Now that's just a trace for troubleshooting purposes. Then the last action is mail server. This is where the environment variables get plugged in. See, I've got them defined at the top here. I've got 3 of them. And the first one is email to ccmp at cisconet.com. The next one is email server 192.168.1.2 and email from, and that's just the from field for the email. So these 3 are just plugged into this last statement here where you see email server and then the 2 email to, and there it is there at the top, and then email from. So it just plugs these into the email message. That's all it's doing, and then sends the email. So to trigger this applet, I'll do a shout on interface gig01 on R2. So I'll shut interface gig01. That triggers the debug trace file. At the bottom here, send email notification to CCMP, and then the interface is down. This SMTP error is because this is not an SMTP server. We'll just re-enable that interface. The other applet is interface bandwidth. Description: this applet will shut down a network interface when bandwidth utilization exceeds 100 kilobits per second, threshold setting. And the event detector is this interface name gig00, and then a parameter statement transmit rate bits per second, entry op GE, entry value, that's a 100,000 there, and that's a pole interval of 1. So that's monitoring that interface for 100 kilobits per second as a maximum transmit rate. And when that exceeds that threshold, Action 1, syslog will send a priority notification message, R2 interface gig 00, high bandwidth utilization alert. And so that'll be part of the syslog message. Action 2 will be then enable. Next one is config T, interface gig 00, and then do a shut, then end. So it's going to shut the interface if it exceeds 100 kilobits per second. Then show interface gig 00, include 5 minutes. That's just going to show the number of bytes and packets on the interface. So what I'm going to do here is, this is gig 00 of R2 that's being monitored by the applet. I'm going to go to R1 and send some pings with large packet size to gig 00 and try to exceed that threshold. There's R1 there. So I'm going to ping 192.168.2.2, repeat 400 times, size 12,000 bytes. I'm on R2 now. I'm getting all these error messages. 5-minute input rate, 116,000 bits per second. So the ping is working. It's sending the input rate above 100,000 bits per second. And now the show IP OSPF neighbor, see now it's only got the adjacency with 192.168.2.553. And that is R3. That's the internet router. So R1, it has no adjacency. This interface is shut down. As a result, I'll just do show IP interface brief. There it is there, gig 00, 192.168.2.2 is administratively down. So that's working okay. And the last applet is on this multi-layer switch, switch 1. I'm going to go to switch 1 now. And this is Event Manager applet switch config. So all I'm doing here is automating the task of creating some VLANs and assigning them to switch ports. This applet will configure access switch ports for hosts. So the first line is event none. So that means I have to run it manually. Action 1, CLI command enable. Then the next one I got 1.1, 1.2 right through to 1.6. So these belong to the same first group. And this is to configure the VLANs. VLAN 10 named data, VLAN 11 named voice, and exit. So those are the two VLANs I want to create, just the data and the voice VLAN. VLAN 10 and 11. Then action 2, I'm going to start a new group here. This will be interface range gig 01 through 3, gig 1 0 through 3, and gig 2 0 3. This is the range of ports that I'm going to assign to the VLANs and make them access mode ports. Switch port mode access, switch port access VLAN 10, and switch port voice VLAN 11, duplex auto, speed auto, and in. Then I'm going to put the results to the console. That's the last line there. Before I do that, I'll verify the current configuration. The current configuration is a default. You can tell there's VLAN 1. They're all assigned to VLAN 1. And that's a default configuration. And to run the applet, it's Event Manager, run, and then the name of the applet. Event Manager run switch config, SWCFG. And there it is. So this is just a message saying this is what the applet has done. So now I'll just go here, and there it is. VLAN 10 data, VLAN 11 voice. They're both active. They're both assigned to the same ports. Here it starts at gig 01 here, VLAN 10 and access mode, voice VLAN 11. And it just goes right through the list here. You can see it's 02, 03, 10, 11. So it's working fine.